Welcome to aminacademy.com and quantity aptitude for many competitive exams regarding number system. Let us do some solving problems. Look at this question. If 1 into 2 into 3 into 4 up to n is denoted by n factorial, then 8 factorial minus 7 factorial minus 6 factorial is equal to. Here, 8 factorial is, for example, here 8 factorial equal 1 into 2 into 3 into 4, 5, 6, 7 into 8. Here, which means up to this, we can write 6 factorial into 7 into 8. That means 8 factorial can be written as 8 sevens are 56 into 6 factorial. Here, we need 8 factorial minus 7 factorial minus 6 factorial. Here, 8 factorial is this, so 8 factorial minus 7 factorial minus 6 factorial is equal. 8 factorial can be written as 56 into 6 factorial, like that. 7 factorial, or 7 factorial up to 7 means here 8. 8 into 7 factorial, and last is 6 factorial minus 6 factorial. So here 6 factorial is common. 56 minus here for 7 factorial, here also 6 factorial. 7 factorial can be written as 7 factorial can be written as here up to this 6 here 7 factorial is up to 6 into here 6 here 6 into 6 factorial into 7 7 into 6 factorial, because 7 factorial can be written as, and this is 7 minus 6 factorial completely out and so on. So which is equal 6 factorial. 56 minus 7 is 49 minus 1 is 48. So which is equal this one. 6 into 8 is 48, and option is C. Yes. Next question. Star means adding 6 times the second number to the first number, then 1 star 2 star 3. First we'll start with 1 star 2. What is 1 star 2 means? Adding 6 times the second number to the first number. First number is 1, adding 6 times the second. 6 into second number is 2. So it is 13. Now 1 star 2 star 1 star 2 star 3 can be written as 1 star 2 is already 13 star 3. which is equal 6 times the adding means adding 6 times the number to the first number is 13 plus adding 6 times the second, 6 into 3, which is equal 13 into 18, so 31. It is 31. So option or then here your check one more time. 1 star 2 is 1 into 6 into 2, that is 6 times the second, so 13, then 13 into then second, that is 13 into 6 into 3 is 18 plus 13. Option is B. Then go. Here, next one, look at this. Here, n for any integer n factorial is this n into n minus 1, n minus 2 up to 1 products. 1 factorial plus 2 factorial to 3 factorial up to 100 factorial. When divided by 5 leaves the remainder. Here, look at this. Look at this. First, every number from 5 factorial onwards, every number from 5 factorial onwards is completely divisible by 5 because every number from 5 factorial, because 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial onwards divisible by 5. So from 5 factorial onwards, 5 factorial, 6 factorial, 7 factorial onwards, even 100 factorial is divisible by 5. And 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial, because it's 5 factorial starts, is adding 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, which gives 1 plus 2 is 3, 9, this 33. So up to 1 factorial plus 2 factorial plus 3 factorial, 4 factorial is 33. Therefore, clearly 33 when divided by 5, 33 divided by 5 leaves 3 remainder. So 33 divided by 5, remainder is 3. Therefore, hence 1 factorial, 2 factorial, 3 up to 1 factorial when divided by 5 leaves the remainder 3. Gives the remainder 3. So answer is D. Next is here. 7 is added to the certain number. The sum is multiplied by 5. The product is divisible by 9 and 3 is subtracted from the quotient. This is the, thus if the remainder left is 12, what was the original number? Here, look at this. Let original number is x. Number is x. So 7 is added to the second number, that is x plus 7. The sum is multiplied by 5 and the product is divided by 9. The product is divided by 9. Then and 3 is subtracted from the quotient. Thus, if the remainder is 12, the remainder is 12 means that 12 is added. Is 3 minus is equal to 12. The remainder left is 12. So then divided by 3 and 3 is subtracted from the quotient. Thus the remainder left is 12. This expression is remainder. This expression says the remainder. Then you have to solve this. How? There is 5ax plus 5x plus 35 over 9 minus 3 goes this side is 15. Then 5x plus 35 equal to 9 into 15 is 135. Then 5x equal to 100, x equal to 20. Option A. Next question. The sum of 4 consecutive even numbers A, B, C, D is 180. Even consecutive number, let it be x, x plus 2, that is B, then x plus even consecutive, that is x plus 4, and x plus 6 is 180. Now, what is the sum of the set of next 4? Here, we have to find x values. X, 2x, 3x, 4x, 2, 6, 12, 180, which gives 4x equal to 180 minus 12 is 168, and which gives x equal to 168 divided by 2 is 42. X is 42. Next 4, sum of the set of next 4, sum of the set of next 4 digits, 42 is the first, then 44, 46, 48, 50 is 212. Here 8, 16, 14, 14, 18, 1 carries, 6, 10, 14, 18. What are the numbers here? 44, 46, 48. Then here. The next is or here. Next is from the 48. We have some wrong here. So x is 42. Then x is 42 means our numbers are 42, 44, 46, 48. This is the first four numbers. Then second set of four numbers is 50, start with 50, 52, 54, 56, which is equal to 212. So option C. Next question. If n equal to 1 plus x and x is the product of four consecutive integers, then which of the following is true? Here, n equal to 1 plus x and x is the product of four consecutive integers. That is, here for first n is the n is 1 plus x and x is the product of four consecutive integers. Suppose n equal to 1 plus x is the product of the consecutive integers 1, 2, 3, 4 consecutive integers. This value is for n because n is given as n is equal to 1 plus x, where x is the product of four consecutive integers 1 plus. Here to 6, 24, it's a 25. Then n equal to next n equal to 1 plus here product of any four consecutive integers, but we are getting 1, 2, 3, 4 only. Now further start for getting some ideas. Then to start with 2, 3, 4, 5. It's a 121, which is equal 121, which is here 5 square you can write. This is a 11 square. One more set will start n equal to 1 plus 3, 4, 5, 6, which is equal is 361, which is equal 19 square. I think this enough to decide the things. Here, all possibilities n is odd integer. N is odd always. Here 25, 121, 6 odd integer, as well as n is a prime. N is not a prime because where here 25 is not a prime, it's not a prime because it's a square of some natural number. Here odd integer, first one is correct. Third is n is a perfect square. Of course, it's a perfect square. So 1 and third is correct. The option is both 1 and thirds are correct. Option D. Next question. Here x plus y equal to 15. X plus y equal to 15 and xy equal to 56. Then what is the value of x square plus y square? Here x square plus y square equal x plus y whole square minus 2xy. That is, if I expand this one, x plus y whole square is x square plus y square plus 2xy minus 2xy, cut that one, x square plus y. Now this is equal 15 square minus 2 into x plus y is 56, which is equal to 225 minus 112. 112. So it is equal to, subtraction is 3, 1, 1, 113. 113. Option B. Next question. 5 square plus 6 square plus 10 square plus 20 square is here 5 square plus 6 square. Here y square plus 1 square means it's starting with 1 means 1 square plus 2 square 3 square up to 10 square minus 1 square plus 2 square 3 square plus 4 square because it starts with 5. Then extra is 20 square. Here the square of n natural number formula is n into n plus 1 by 2. N is what? 10 into n plus 1, 11 and 2n plus 1, 20, 21 by 6 minus same n is 4 here. N is 4 means first n is 4 into n plus 1 is 5, 2n plus 1 is 9 over 6 plus 400 because 20 square. Here 6 is 2 3s are 7. Here 5. So which is equal 11 into 5 into 11 is 55, 55 into 7, 385 minus 30 because 4 into 5 is 20, 20, 180 by 6 is 30 plus 400 which is equal 755. So we have the option A. Now next one, 1 plus 2 plus 3 plus 4 up to 10 is 55. You know that. Here 6 plus 12, start with 6 plus 12, 6 plus 12 plus 18 plus 24 up to 60. So take 6 out. Here 6 out means 1 6 are 2 6 are 12, 3 6 are 4 6 are 24 up to 15. Is that? Now we have 6 into here this is 6 into 15. 16 here 1 2 3 4 5 up to 15. Up to 15 is this is not here. It's not 15. It's at 10 because 6 into 10. So 60 because 60 is there, 6 into 10. So this is equal to 6 times 10 for up to 10 addition is 55. So 5 6 are 30, 3 carries, 5 6 are 30, 3 30. So option B. Look at this important note here. Any factors that is x power n minus a power n is divisible by the factor x by a for all values of n. For all values of n, it is divisible. Next is x power n minus a power n is divisible by x plus a for all even of n. Then x power n plus a power n is divisible by x power a for all odd of n, all values of n. Then for to find the highest power of the prime numbers p in n factorial is this is the condition n by p plus n by p squared like it's closed where p is n is in between this. Now regarding this we will do some questions. You can understand the concept. What 9? Question number here. If n, m and n are natural numbers such that 2 power m minus 2 power n is 960, what is the value of m? Here 2 power m, here this expression 2 power m minus 2 power n is equal to 960. Therefore, you can say 2 power m must be greater than 960 because it's equal to 960 for 2 power m minus 2 power n. When the least value of m is 10. Now, here 2 power 10 is 2 power n is 1024, but here it's greater than 1024, greater than 960. Therefore, we can say 2 power 10 and 1024 minus 960 equal 64. This 64 must be 2 power n. 2 power n is 2 power 6. Therefore, here m equal to 10 and n equal to 6. So our option they are asking about value of m is 10. A. Here, next question. Look at this. Here, the number 1, 3, 5 up to 25 are multiplied together. Then the number of zeros at the right end of the product. Suppose here look at this. Clearly 2 and 5 together yields 0 because if you this multiplication number is the multiples of 2 and 5 together yield 0. Since the product of odd numbers contains no power of 2. These are odd powers. Power of 2. So that the product does not use 0 at the unit. Here, this product of 1, 3, 5, these are odd number product. And in that, here the multiples of 2 and 5 together yield 0. Multiple of 2 and 5. But here there is no 2 here. 0. Since the product of odd numbers contains no power of 2. Here there is no power of 2 because these odd numbers have no power of 2. And so that it given the product does not give 0 at the unit digits. That is, there is no 0 in unit digits. Here 50, that is one. Next question. The number 1, 2, 3, 4 up to 1000 are multiplied together. The number of zeros at the end on the right of the product. How many zeros at the end of this product? Next, the question. Your n is, our number n is 1 into 2 into 3 up to 1000 here, which is, we know that it is a 1000 factorial. Now, clearly the highest power of 2 when n is very high as compared, highest power of 2 is very high than highest power of 5 in this product. So the number of zeros in n will be equal to the highest power of 5. Therefore, required number of zeros. Number of zeros is 1000 5, then plus 1000 by 5 square, 1000 by 5 cube, 1000 by 5 power 4. By roll this here, over this rule, this. Now, for this gives, it is 200, because this 5000 by 25 is 8, 200, so 40. Because 1000 by 25 is 40, plus 1000 by 125 is 8, plus 1000 by here, this is 1 point something, that the whole number is 1, because 1000 by 625 it's 1 point something, so the whole number is 1. So which is the possibilities is because it is the rule is lesser or equal to here. So which is equal to 49. So 49. Option D. The number of zeros at the end of the product of this 5, 10, 15, 25, like up to 50 is here. Look at here. N is 5 into 10 into 15 up to 50. So here, which is equal, we can say y into 1 into 2, 1 into 2 into 3, because factor common 5 up to 10, which is equal y into 10 factorial, which is equal y into 10 factorial. Here the highest power of 2 in 10 factorial, highest power of 2, and 10 factorial is 10 by 2, 10 by 2 square, 10 by 3 square, because by 2 square, 2 cube, sorry. Here it is 8. So 8 is lesser than 10. Suppose 10 to power 4 you cannot take, because 2 power 4 is 16, it is greater than 10. So which is equal here 5. Here 10 by 2 factorial, 2 square is 4. It is 2.25 comes, but you have to take 2, the whole integer. Here also here 1, because 10 by 8 is the whole number is 1. So which is equal 8. So for n is so 8. So here 8. Option is 8. Next, the number of zeros at the end of 6 factorial. 60 factorial. The highest power of 2 is much higher as compared to the 5 factorial and 5 in 60. Here, in this 60 factorial, you know that it is starting with 1, 2, up to 60 factorial. 60. Now, in this, which is higher factors, of course, 2 is the highest higher number of factors than 5. So, required zeros, that is equal to highest power of 5 is the power of 5 equal 60 by 5 plus 60 by 5 square. Here, 60 by 5 is 12. 60 by 25 is 60 by 25, 2. Here, y 5 square is 25, 60 by 25, 2 point something is, so whole number is 2. Then it is equal 14 zeros. So answer 14. Option B. Next question. The unit digit unit digit of 13 power 2003. Look at this. Or we have to split this to 2003 less, like 2 plus 3 power 4. 3 power 4 is what? 3 power 4 is 81. Unit digit is 1. Then next we can say 3 power 4 into 24. Also unit digit is 1. But 4 into 24, next 3 4 like this, we have to 3 power 4, 500 is 3 power 4, 2000, but we need the 2003. So this also Here 344 is 81, so 1 is unit digit. 3 4 500, 4 into 500 gives 3 4 and 343 check here. 343 is 27, therefore unit digit is 7. Therefore 3 power 2000, 343, that 3 2003 can be written as 3 power 344 into 500 and 3 power 3 or 1. So, which is given 3 power 2003. Therefore, total is 1 into 7 zeros in unit. The units digit of 13 power 2003 is 7. So, option C. Next is the digit in the unit place of the number 67 power 25 minus 1. Here, same procedure, 67 power 25. The unit digit of now unit digit of 7 power 25, because 67 can be split as 60 plus 7 is unit digit of gives this one. Next one, unit digit of 7 power 25, which is equal 1 into 7, which is equal 7. Hence, the sum of unit digits, therefore, 67 power 25 minus 1 is 7 minus 1 is 6. Therefore, the digit in the unit place of the number is 6. Answer is 6. So far we discussed about quantitative aptitudes, some solving problem regarding numbers. If you have done, please subscribe our YouTube channel.